Topic is all about Zoe slab. It's a slab supported by beams on all the four sides, and the loads are carried by the supports along with both directions. In Zoe slab, the ratio of longer span L to shorter span B, or you can just use S, just a short, is less than 2. So this is longer span over shorter span equals L, L over B, or L over S less than 2. So, and this is a one-way slab. L over S greater than 2. So, it considered two-way slab if S over L is greater than or equal 0.5 but cannot be equal to 1. So, this is the pictures, and this is the rock bars, main steel. So, these are reverse that we can see. This is a two-way slab because they have bend her and bend her, so this is equal. So we have a example problem. Two-way slab, design a two-way slab by coefficient method. So this is our problem. Design the spacing of 12 mm diameter rebars along the short direction with strip of 4 meters times 5 meters times 150 millimeter thick corner slab carrying a superimposed dead load of 4 kilopascal and live load of 4.8 kilopascal. Concrete equals 23.54 kilonewton meter squared, and Fc prime equals 28 megapascal, and Fy equals 350 megapascal. So this is our solution. So so we can so according to the problem, we are design a corner slab. What we are going to do is we find the coefficient for computing the moment which is necessary in designing our rebars. Let us first compute Rw. So let's just compute Rw first, and the next is to our problem. Our superimposed dead load is 4 kPa or kilon Pascal, and our live load is 4.8 Pascal. So this is the solution. So DL equals dead load or the weight of slab or the weight of concrete, and the thickness of this equals 150 millimeters. So this is the concrete 23.54 times thickness. So we can use as a meter, so that 150 equals 0.150 is equals to 3.531 kilonewton meter squared. So the weight of superimposed dead load is equals to 4. So we can add here to get a weight of dead load. The weight of dead load is equals to 7.531 kilonewton meter squared. So according to in SCP according to our NCP 2015, our W ultimate is equals 1.2 times W weight of dead load plus 1.6 weight of live load. So we can just separate this to get individual. Uh, so dead load. So as we can see, 1.2 WD or weight of dead load equals 1.2. So our dead load is equals 7.5 7.531. So our weight of dead load is equals 1.2 times 7.531 is equals to 9.037 0.7. So our weight of live load 1.6 times our weight of live load is equals to 4.8 kilopascal. So it equals 7.68. So we can add this. So the weight ultimate is total is 16.7172 kilonewton per meter squared of area. Now, according to the problem, we will have to design the rebars in the short direction. Rebars in a short direction in a middle strip. What is a middle strip? So now, so this is what we call a middle strip. So this is the edge of L over 4 and the edge of L over 4. So this is L over 2. So this is a middle strip and this is a column strip. So as we can see, if we can do this, so our rebars will do like this. Like this. So we can see the bend here. So if this bend, so this is a positive moment and a negative moment. So as we can solve the solve as we can solve the negative moment, so we can use our table in the coefficient moment. So we have a table, but I just send letter. So the M equals that. This is a short span, so that the coefficient of a negative moment for the short span is equal to 0.071. So that in this coefficient we'll have a negative mu is equals to coefficient S or C is WU S. So why we can use S? Because we are a short span, so we can use S. But if we are a long span, so we can use this L. So our mu, so our CS, as we see this coefficient of short span is equals to 0.071 times our WU. So as we can see here, our WU is 16.7172. So we can put her W is 16.7172, and our S is 4. So as we can see here, this is 4. So this is our S. This is our short span. So we calculate. So the equals is 18.29 kilonewton meter. To be safe in picture, so at our mu actual is less than or equal 5 BD squared if C prime Q times 1 minus 0.59 Q. So our mu, so as we can see here, mu is equals to 18.59 times 10 over 6. So this is a unit of kilonewton meter. So we can use a unit of kilonewton millimeter. So we can use 18.29 times 10 over 6, or this done or equal 0.9 times our pi, which is 0.9, and b, which is taking 1 meter, so can use a millimeter, so 1000. And our d, how did you get our d? And the d is 150 mm thick for the corner slab. So we have this. So this is minimum of 20 mm, and this is the half bar of diameter. So I'll be using a 12 millimeter. So this is 6. So as we can get RD, so we have a 150. So we can just subtract 20 plus 6, 26 minus 150. So we can get RD is equals to 124. So let's just, so how did you get RD? So this is our thickness, 150 mm. So just, this is minimum of 20 mm, and this is the half bar of diameter. So I'll use a 12 mm. So we can get the 6. So to get to get this 6, so to get our D is we can just subtract the, so we have a 20 and 6, so 26, so subtract the 150, so we can get a 124. So our D, we can just substitute here. So our D is equals 124 squared, and our FC prime, FC prime is equals 28. So as you can see, so as you can see, as you can see, the most book this is used designated as W, this Q, but I use the old symbols of ECIQ because W normally is used uniform load so that there is no detection of symbols. So I just use Q so that to input this in a calculator and to solve, so that we can get this answer of Q. So as we can, so we can solve our rho. So our rho is Q C prime over Fy. So R is equals Q 0.05052. Q prime is equals 28 times 28 over Fy equals 350. So it equals 4.0416 times 10 raised to negative 3. That is our P minimum. That is our rho minimum. So as I said, the value of this is bigger than the rho minimum. So we'll just calculate. The rho minimum bigger of 1/4 over Fy, and if square root of C prime over 4y. So this is 1.4 divide 350 equals 4 times 10.3, and square root of 28 over 4 times 350 equals 3.78 times 10 minus 3. So the bigger of the two is 4 times 10 minus 3. So this is bigger than row minimum is okay. We will adapting to our design. Therefore, we can just compute our ES. So therefore, our ES is TBD. So our row minimum is the ES. Our ES is equal to row times B times D. So our row is equals to 4.0416 times 10 is a negative 3. So our row is equal 0.00400416 times this is a 1000. So this is a 1000 times our D equals 124. So our ES is equals to 501.16 millimeters squared. If we will convert this in number of bars, 12 millimeter, so we have our ES is equals to 501.16 meters squared, millimeters squared. How many in squared in one bar? So it has a pi over 4 times 12 squared. So equals 431 pieces over 1000 millimeter. Now, since it is not limited to 1 meter, it is actually a 5 meters. As you can see, so we can convert this spacing. So convert it this spacing of our convert it to the spacing of our millimeter bar. So we can just reciprocal of this. So 1000 mm over 4.431. So this equals 225.67 mm. So as we can see, we can just this is the answer of the spacing of negative moment. So the row minimum, this is a 3 minimum that we can just are required by university. So we have a 3 minimum and the second is our temperature. This is we can use a temperature change bar. So in our temperature change bar, so is AST is equals to 0.002 is so across area. So 0.002 and 1000. The gross area is 1000 millimeter times the depth of 150. So this is going to be a 300 kilometers squared, which is this done about A divided by picture. So 500 01.16 round picture. So this is more than the required of temperature required by the temperature bars. So this one is still reverse. So this is the minimum. First is the row minimum for picture. The second is the A is minimum for temperature. So the other one is by spacing. Is cannot be more than, it must be less than 3 times the thickness and 450 mm. So 3 times the thickness is 3 times 150 is equals 450. So the smaller 450 is 450.